Okay, so here's a video for 8.6, vectors in space. There's one new topic, but the rest is all the same material, just now we work in 3 dimensions instead of 2. So normally we have an x and y, x and y axes, but now we're going to have an x, y, and a z. So x, y, and our z. And we kind of go like that back into space. So z, x, y. Alright? But everything else pretty much stays the same. Last time we had A1i, B1j, and A2i, B2j. Now we just have this third variable, k. C1 and C2k. So for our dot product, it's exactly the same. A1 times A2 plus B1 times B2 plus C1 times C2. Alright, so if we're given 2 vectors, vector V looks like that, vector W looks like that, and we want to find the dot products. We have 2 times 5 plus negative 3 times 3 plus 1 times negative 2. Okay, so that's going to end up with 10 minus 9 minus 2 for a negative 1 dot product. Alright, and the reverse would be true. Negative 1 here, just like it was in the last section. V dot V. So let's find V dot V. Again, we get 2 times 2 plus negative 3 times negative 3 plus 1 times 1. So we end up with 4 plus 9 plus 1. So that's going to end up equaling 14. Okay? And just like before, the magnitude squared will be V dot V. Alright? Same exact thing. So if you wanted to add V and W together here, we would do the same thing we did before. V plus W is going to equal 2 plus 5 I plus a negative 3 plus 3 J plus 1 plus a negative 2 K. Alright, so we end up with 10I plus 0J minus K. Or if you simplify it, 10I minus K is your V plus W. Alright? And if you wanted to multiply, say, I don't know, let's go with like 2W. Well, again, we get 10I plus 6J minus 4K. Okay? So we've got functionally so far, everything we've done so far is exactly the same, except now you've got a third dimension. Okay? Third dimension.